Welcome to Channel Cosmic Journey. Today we are peering into the most terrifying, fascinating, and mysterious abysses in the universe. Black holes. Imagine an object with so much mass packed into such a tiny space that its gravitational pull is absolute. Nothing, not even light, the fastest thing in the cosmos, can escape it. They are the ultimate cosmic trapdoors, places where the very fabric of space and time bends until it breaks. To understand how these monsters are born, we have to look at the life cycle of massive stars. When a star that is vastly larger than our Sun runs out of fuel, it can no longer support its own immense weight. In a fraction of a second, the star collapses inward while its outer layers explode in a violent supernova. If the remaining core is heavy enough, gravity wins completely. The core crushes itself down smaller and smaller until it becomes an infinitely dense point, known as a singularity. Surrounding this singularity is the point of no return, called the event horizon. Think of the event horizon as the invisible boundary line of the black hole. Once you cross this threshold, the escape velocity required to get out exceeds the speed of light. Because no light can reflect off it, escape from within, a black hole is completely invisible to the naked eye. We only know they to probably never experience. You wouldn't just see pitch blackness. You would see a swirling, glowing disk of gas, dust, and stellar debris trapped in its gravitational grip. This is called the accretion disk. The materials in this disk are spinning at friction-inducing near-light speeds, heating up to millions of degrees and radiating brilliant X-rays across the cosmos. What would happen if you fell into one? As you approached the event horizon, a bizarre phenomenon called spaghettification would occur. Because gravity pulls much harder on objects closer to the center. If you fell in feet first, the pull on your feet would be exponentially stronger than the pull on your head. You would be stretched out into a long, thin string of atoms. Even stranger is what happens to time. According to Einstein's theory of relativity, massive gravitational fields slow down time. To an outside observer watching you fall, it would appear to slow down as you neared the event horizon. You would freeze at the edge, fading into a faint red blur as the light waves stretched out, seemingly stuck in time forever. But from one perspective, you would plunge right through the horizon in an instant, hurtling towards singularity. For decades, scientists found black holes keep returning, slowly swallowing the universe piece by piece. However, physicist Stephen Hawking discovered that they actually leak a tiny amount of radiation over time, appropriately named Hawking radiation. Because of this, black holes are slowly losing mass and will eventually, over trillions of years, evaporate in a final, silent